Okay, exponents and exponent rules. This is a new topic, and I'm not going to lie, it's tricky. There are lots of little rules and little things we have to practice and keep straight, so let's jump right in. So by the end of today, I'll be able to recognize the parts of a power, and I'm also going to be performing some operations with exponents that in our traditional operations of multiply and divide, and we're going to see that they behave differently when we have exponents. So this is the terminology we need to know. A power is the whole package. Okay, the exponent is the little number that's raised up. Okay, and then the base is what's on the bottom. Now what that means is I have 2 to the exponent 3, that's how it's said, or 2 to the third, or 2 cubed. Okay, there is some language that goes with this. And what it means is a shortcut for repetitive multiplication. So please note, that's different than multiplication is a shortcut for repetitive addition. Exponents represent repetitive multiplication. Okay, so this is what it can look like. We have exponential form down the left side here. Okay, and you can see there's a bunch of different terms. And then we have something called expanded form. And so if we look at that, 2 cubed would become 3 2's all multiplied together. 5 to the fourth would become 4 5's all multiplied together. Now here's where we have to be a little careful. Notice the bracket around the -3. That means the whole thing is multiplied by itself. So we keep the brackets and we show that there are 2 bracketed -3's multiplied together. And then lastly, we start to get into our algebraic expressions, which is where we're headed with all of this. You can see that there are 3 brackets of a plus 5 all multiplied together. Now you don't need to know how to do the last one. I just want you to see where we have to go with this and why it's important to understand the concepts at a very fundamental level. Okay, popular powers to know, and this is available on my website. You can download this. This is just a little table that will help keep track of things. So the bases are on the side here, the exponents are on the top. So if you were looking at, let's say, this value right here, this would be a base 4 with an exponent 4. Okay, so if you looked at 49 over here, this would be 7 squared. Okay, so you have the base on the left side, the exponent on the top. I've summarized that over here for you. And again, you can download that. So multiplication of powers, this is our first rule. So if I had 4 times 8, we should see that the answer for that is 32. Okay, now what I'm going to do is I'm going to decompose or deconstruct these numbers in a slightly different way. So the 4 is the same as 2 squared, and the 8 is the same as 2 cubed. And if you have to, you can jump back here, and you can see 4 is the same right here as 2 squared, and 8 is the same as 2 cubed. Okay, so that's how you could use the table just until we get a little bit more familiar. If we look at this in expanded form, this 2 squared becomes 2 2's multiplied together, 2 cubed becomes 3 2's multiplied together, and now what you should see here is they're all multiplied together. We've talked about the order of multiplication, whether it matters or not. If we were to count all of this up, we would have 5 2's all multiplied together. Okay, so this is 2 to the 5th. Now, if we go back to our table and we look at 2 to the 5th, so I'm going to go to 2, I'm going to go over to where I have a 5th, and oh my goodness, I find the 32 that I expected to find. Cool? Okay. Let's try the next one. Here we go. 9 times 81. Okay, so bigger numbers. So 9 times 81 is 729. Now if I deconstruct those values, 9 is the same as a 3 squared. 81, you can go back to look at your chart if you need to, is the same as 3 to the 4th. So what we're looking for are terms that have the same basis. Okay, that's a really important concept. So now you can see there's the 2 3's from the 9, there's the 4 3's from the 81, and if we count all of those up, we have 3 to the 6th. Okay, so now if we jump back to our table and we go to 3 to the 6, so I didn't write it down, that would be 729. Okay? All right, now what if we don't have numbers? What if we have variables or unknowns that are our bases? Okay, so we have a to the 4th times a to the 7th. Well, there's the first 4 terms. There's the next 7 terms, and because they're all multiplied together, the order doesn't matter. So I can look at the entire package together, and I can see that this is a to the 11th. Okay, and so hopefully by now you're starting to see a little bit of a shortcut. And that shortcut would be when we have the same bases, and this is super, super important, these bases, when they're the same, whether they're numbers or letters, and we're multiplying them together, we can add these two exponents. Okay, and that seems like a really simple rule, and it is when you see it isolated, but lots of people make a lot of mistakes in this because they start mixing up adding and multiplying. Okay, so let's take a second here. Pause the video, write down your 2 answers for these two, and then we'll carry on. Okay, so welcome back. Now, I'm just going to do this in a slightly long form just to remind people of what we're doing. That's what you have written there. So now I would expect our destination or our goal is to go from the first line to the last line, but while you're learning, you may have to write out some in-between lines, and that's totally okay. So this should be 2 to the 7th. Okay, now down here we have bracketed terms, which is really important to keep track of. So again, if we were to write this out in an expanded form, which is a good way to learn until we get really comfortable with the rules, we would see that we have 6 negative 3's all multiplied together. So we would say that's negative 3 to the 6th. Okay, now we've seen this pattern before. This is just a slightly different presentation of it. You don't need to write it down, just watch for a second. So if you have negative 1 squared, that's negative 1 times negative 1, and you get positive 1. If you have negative 1 cubed, that's 3 negative 1's all multiplied together, and you end up with negative 1. Now, we've talked about this before, the even and odd number of negative signs in a multiplication division problem. So all of the even numbered powers are going to produce positive values. All of the odd numbered exponents on this negative 1 are going to produce negative values. Okay, so just one of those little things you can watch for that can make your life a little quicker and easier. Okay, now again, notice the difference here. This is a big difference with powers. This is negative 3 times negative 3. This is a negative out front of a 3 times a 3. Okay, and if you wanted to, you could put a placeholder of a 1 there if that makes it easier to see. The value here would be positive 9. The value here would be negative 9. Okay, so watch for that. This is normally sometimes more of a subtraction issue over here. Your calculators may have trouble with it, so be very much aware of that. All right, second rule, division of powers, and we'll do it very similar to the first rule. So 16 divided by 8, how many 8's fit inside of 16? Well, 2 of them. And now I can deconstruct or pull those numbers apart. So 16 is the same as 2 to the 4th, and 8 is the same as 2 cubed. Okay, now I'm going to rearrange the division, and I'm going to write them one over top of each other. So you can see there are the 4 2's from the 16. Here are the 3 2's from the 8. And if we look at this and we say, well, what's 2 divided by 2? Well, those cancel for a 1. Cancel for a 1. Cancel for a 1. And you end up with 1 times 2, which is just our answer of 2 to the 1. Okay, and I'm going to put the 1 there. You don't have to put the 1 there. It's written. All of these values right here have a little 1 there. We just don't write them. But I'm going to put it there just so we can try and observe the shortcut. Some of you have probably already seen it with one example, but let's try another one. So 243 divided by 9. Oh my goodness. 9, 27, 81. Uh-oh, I'm in trouble here. So we may have to deconstruct these. Might be too big for my brain to handle, and that happens at times. Okay, so now 243 I could get from my table. That's 3 to the 5th. 9 deconstructed is 3 squared, and if I write them out in a division sense, I can start to quickly see, okay, that I'm going to have 3's that cancel. So these 3's will cancel, these 3's will cancel, and I will be left with these 3 terms. Okay, which means I have 3 cubed as my answer. Okay, so now that's a little easier to handle. So if you remember, that's 3 times 3 times 3. So there's 3 and 3 is 9. 9 and 3 is 27. Which seems 3 times 3 9 is 27. Yeah, that works. Okay, second guessing myself there. So the answer for this one would be 27. Okay, but mostly what we're interested in is to see how we set up the exponents. So let's try another one. This time we'll take away our numbers and we'll put our base value in there of just an a. So I guess I could do it. 3, 4, 5, 6, 7, 8, 9, 10. Okay, and you can see why we wouldn't want to consistently use expanded form. It starts to get a bit cumbersome. So now I have 10 a's on the top, 6 a's on the bottom. Those all cancel for 1's, not 0's. They cancel for 1's, which leaves me with those 4, and I have a to the 4th. Okay, so now I think you can probably see the shortcut by now, and here's the shortcut. Okay, so when we are dividing powers with the same bases, it only works with the same bases, we can subtract the exponents. Okay, so let's try one. Pause it here and take a try of these two. Okay, so now if the first one with the m's, the first thing we check is are the bases the same, and if they are, then we can use our exponent rules. So this should be subtract the exponents. So this becomes m to the 4th. Over here I have the same basis, so this becomes 10 minus 7 as an exponent, which becomes 2 to the 3. Now the m to the 4th, you can't evaluate or get a number. 2 cubed over here on the right hand side, if you wanted to, you could continue and go to the value of 8, but normally we can just stop at the exponents, the exponential expression, because that's usually all we're looking for. Okay, so what if we have mixed terms? And please highlight this right here. Different base terms do not combine. Now, if you wanted to, we could take advantage of our order of multiplication not mattering, and you might want to just rewrite this like this. Okay, so the terms with the base 2. So this would become 2 to the 7th. This would become a to the 8th, and that would be as far as we could go. Okay, so mixed terms, and this is one that gets people. Again, I would do the same thing here. I would rearrange. Make sure I've copied it all down right, and then I would say these first two terms, they're multiplied together. I can add the exponents. And then the same thing over here, I can add the exponents. And here's where things start to fall apart. Because there's no a's or b's or m's or anything, people will start to make up rules, and they will tell me that the answer here is 6 to the 11th. Okay, you cannot do that. These bases here are not the same. This cannot happen. Okay, and you can test it on a calculator if you like. I'll be happy to go through that with you more. But for now, let's just understand that the bases have to be the same for anything to be combined. Okay, so slightly different type of problem. What I would encourage you here is to look for what I call columns. So there's one column. Second column I didn't highlight. Third column I highlighted. Okay, so this is just a collection of 3 problems that we're going to do independently. So the first one is division. So 5 to the 4th divided by 5 squared. That's the first part. The second term, a to the 6th divided by a to the 4th. I would be subtracting those exponents. And then the last term, I would be subtracting those exponents as well. And by the time I'm done, I end up with 5 squared times a squared times b to the 1. And that would be good there. Or it may be written like this, And notice whether you write the 1 on the b or not doesn't really matter. Okay, so there's the summary of your first 2 exponent rules. Make sure you have those written down somewhere. I'm also going to post it as a PDF with all of the rules on one page to make your life a little easier. And then there's a couple of questions to try from your text. Thank you for tuning in.